Our first presentation is developing Python packages from Vitor Baptista. He may go the entire time, but if there's time left at the end, there will be questions at the end.
Okay, good afternoon, everyone. See you a bit later after lunch. Great to see such a packed room. So I'm Vitor Baptista. I'm a software developer. I'm also call myself a civic hacker. I work for the Open Knowledge International with public data and public information, and I'm gonna walk you through the developing Python applications. Okay, so can you all hear me? Fine? Okay, great. So let's develop our first package, a very simple hello world package. This in the top here, we have the folder structure. Basically, we have a folder hello world, which inside has another hello world folder with our init.py file to tell Python that this folder contains a package. This init.py file just has this simple hello world method. And we need also this setup.py to organize the metadata about the package, like the author, the title, the version, and this kind of things needed. Okay, so it's just these two files, one folder. Let's try and see if it works. We need to build a package. To do that, we just call this Python setup.py as dist and bdist wheel. We are building two types of packages. It's a source distribution, it's a wheel. Not have time to explain the differences, but please look it up if you're interested. So we have these two files in the dist file inside our folder that are our package. So let's try. Does it work? We can try already using pip. We can just go and pip install with the package name, with the targd. So just pip install it, many messages installing, and then if everything works well, we can just run the Python interactive shell and already run like import hello world, our package, and already call our method in the package. So yeah, it works. Now let's try to publish it. It's in our local machine now, so let's publish it to PyPl, which is a repository of Python packages. To do that, first we have this PyPl. It offers you a test server, so you can try if the package is all good and all fine before really going to the real deal. So you need to go to the pytest server, like create an account, and create this file in your computer, the .pypyrc with just like your username and password is the contents of the file. And then we can go back to our package. And here we are using Twine, which is the recommended way of registering and uploading packages because it ensures that it's not sending your password unencrypted through the wire, and there's a few other advantages using that instead of like the regular just setup.py. We need to register the two packages that were created, the dist, pyok, and these two others, with this -r test to tell it that we're using that pytest instance. And then we just do twine upload -r test and our package. It's gonna upload PyPl test, and then we can try installing directly from PyPl. Pip install. The name of the package would be Pycon UK _ hello world. Hello world was already taken. Surprise. You just need this -i with the repository, the PyPl, because we're using the test PyPl and not the official PyPl server. It's gonna go to PyPl, collect, install the package as usual, and then we can just try it, like open the Python shell and try importing, and hopefully everything will work well. If so, we can publish to the real deal, to the real PyPl server. It's the same way It's the same thing that we need to do, like go to PyPy, register an account, and add that new account to your .pypyrc file with your repository, your username, your password. Register again with the Twine, same way we just did, and upload it to the real PyPy. And congratulations, now everyone can do just pip install Pycon UK_hello world and get your amazing package. But that's not enough, so let's improve it. Let's, in the repository, add a few files first. We need to add a gitignore to make sure we're not adding new unnecessary files to our repository. Write a README file. Please, unless you have a very, very good reason, use restructured text to write a README and not Markdown, because PyPy don't support Markdown yet, and it helps you for a README to appear well on PyPy. You also need to write a README file in the repository, and then on setup.py, you just add this long description there's this read function that just reads a file and returns it as a string into setup.py. Next, add classifier. That's basically metadata that tells things like what Python versions are supported, what OS are supported, and the alpha or beta or production code, and what the license that you're using. Add a license file. Please add a license to whatever code you're using, or everything that you use, add a license. Otherwise, people can't legally use it. Copyright is totally broken, so please don't make it worse. Add a setup.cfg file. This is basically, this tells pip that this is our package works on Python 2 and Python 3. I'm not going to go into details, just if that's the case, just add the setup file. Add a manifest.in file as well. When you're creating a package, Python is adding a few files by default, like .py files, like the setup.py itself. But sometimes you want to add more files. For example, in this case, we want to add also the license file into the package. And so that's why we need a manifest.in. Sometimes we also have some data that you want to distribute with your package, CSV or image or whatever. So add this manifest.in file. And this is our current structure. So we just have the initial one with the init.py and setup.py and these few other files. Here I will also suggest to just a small refactoring, as in remove the method from the init.py file and add it to a separate file. I just find it nicer and cleaner to have in a separate file and not in init.py. But it's the same. Look, init.py, you're just gonna import your new file, and the function would be in that new file. Okay, so the most important thing when developing this package, please testing. Do the test, write test. There is this very good book, Working Effectively with Legacy Code, that has this definition, what's legacy code? It says legacy code is code without tests. As in, if you don't have tests, you can't refactor your code, you can improve the code base while keeping sure you're not introducing new bugs, you're not modifying the behavior of your code by mistake. So write tests. There are many different types of tests. There are tests that check if the code works as you would like it to work, as you intended. There are tests that try to check the code structure, if the way the code that's written is good or not. There are tests that check for common security issues and many others. We'll go through a few now. But before writing the actual tests, we're gonna install a test runner that helps you to organize the test suite and helps you to be able to run the tests with a single command. Here I recommend using Tox. Tox is a very, very, very good test runner, and everybody's using it. So just pip install Tox, and that's okay. And now we're gonna configure Tox, and also configure our test framework. The test framework is basically a framework to allow you to write a test, to assert that the output of your code is what we expected. There are many test frameworks like unit tests, nose tests. The one I like the most and the one I recommend is PyTest. And so we can go to configure talks with PyTest. We just create this talks.ini file in your repository. This is the contents. So just create this talks part. Here we have the environments that we want to test against. This code, amazingly, it works on many different versions, Python2 and Python3 as well. And talks helps you to run the code on many different versions of Python. So here we just say the environments will be Python2.7 and Python3.3, 3.4, and 3.5. We are adding these skip missing interpreters. So like if someone downloads your code and tries to run the test locally, if they don't have all the Python versions that you support, the test will still will ignore the Python version that they don't have. And then we need to configure the actual test environment, which is this last test env part. Hopefully you can see. Set the dependencies for tests. Our dependencies so far is just pytest. And the commands, which is simply py.test. And you have this post args that are just allow you to pass arguments to pytest, like for running just a single file, for running the variables and that kind of thing. So saving this file, this is our structure now. We are writing our first test now. So creating a new folder, a test folder, create a new file, test_hello world. The usual pattern is to do like test underscore and the name of the file that you are testing. In this case, we're testing hello world.py, so test_hello world.py. And the actual code is just we import the hello world. I like to organize that inside a class. That's not necessary. That's just the way I like to work with. You can just like write the function without a class if you prefer that. And then the function test underscore and a description of the test. Like test, it returns the hello world. And here we're just asserting that the method hello world returns hello world. Good, simple. Now let's run it. To run, you just go to your terminal and do talks. You're gonna get to like it will install your dependencies and install your package for each environment that you asked it to, like Python2.7, 3.3, etc. And by the end, everything goes well. You're gonna see things like this, like each environment and if it succeeded or failed. If you don't have one of those Python interpreters in your local machine, you just ignore it. Cool. So now let's improve it. Now adding code coverage calculation. So when you're testing, it's also useful to have the calculation code coverage. So it tells you what parts of the code was executed, what lines of the code were executed while running your tests. So you can see if there are some parts of your code that you're not testing against. And to do that, just go to your talks.ini file, add a new dependency, this pytest-cov. We need to add this use develop true and add this new argument to the pytest. Okay. Go a little bit faster. Again, run talks, and it will tell you the coverage of the test suite. We have 100% of coverage. Great. This is not something you really need. I mean, 100% coverage does not tell you that your test is good or your tests are bad. It's just use the coverage more as an instrument to tell you what you're not testing, but don't try like to be okay. We need 100%. That's no need there. Then linting. Linting is to test your code structure, testing that the patterns that we are using, like the way you are structuring your code is correct, like that you're not importing a variable and not using it, that you're not using camel case or more structural issues with your code. To do that, we just add this to the env list of our talks. We have like Py2.7, Python3.4. We add this new environment lint. I'm calling that lint. You can call it anything. And you create this new environment, just the test env column lint. And again, what's your dependencies for that environment? In this case, it's just flake 8. There are many different linters. I'm using flake 8. There are like PyLint. There are others that you can use as well. This is just the one I'm using here. And the command is just flake 8 dot. Again, if you run talks, this is a good thing. Like when you run talks, by default, it will run all your environments, which in our case is all the Python environments, and now we're adding this new lint environment. But you can also run like talks-e and just a specific environment. While developing, I like to just run like Python2 and Python like 3.5, just to make sure like the tests are running faster and it get a tighter feedback loop between writing code and writing tests and running the test. So we have the first failure. If you run like talks-lint, it's gonna complain that our init.py is importing a package, but you're not using that package, which is totally fine in this case because that's like we're not using that on init.py anyway. So we can just change the init.py with these comments, no QA, and the name of the test that is failing to ignore it. Cool. Moving on, we have the security linter as well, which is like the same basic idea of a linter that's looking your code and looking how you're writing it and how you're structuring it to check for some conditions, but looking for security issues and like maybe you're calling a shell command, a bash command with user input that can create a security issue and some other different tests. Again, we just add the security environment to the env list, so it's run by default, and create this new environment. Set the dependencies as bandit. This is a tool by the OpenStack guys. And set the commands bandit -r dot. We also need to, like, if you run this right now, it will try to not only run for your own code, but also all Python files that are in the folder that we're running, including, for example, the virtual environment that you're having, your dependencies, and that's not what you want. So you can create a .bandit file to tell it to ignore a few folders. And run again, talks-c security, and hopefully it will find no issues. And now, also, we want to validate the setup.py. That your setup.py, the metadata, you're adding the needed metadata. It's valid. Your README, your restructured text is valid as well. Again, just add the environment, create this new environment, set the dependencies, and the command for that, and you can run it. Also validate the manifest. Like sometimes you add a new file to your repository. It's very common. You add a new file to your repository and you forgot to add that to the manifest. So when you create the package, it's not included in that package, and so it fails. To avoid this kind of very common error, what you do is this check manifest dependency. That's very, very useful. Again, it will tell you, basically it will tell you all the files that you have committed to your repository that will not be included in a package. Some of the files you don't want to include anyway, like this .bandit file, like the tasks, like the talks.ini file. So you just configure to check manifest what to ignore, and by adding in your setup.cfg file this what you want to ignore. Cool. So that's it for testing. You have the test suite. You're testing for code structure. You're testing for security. You're testing that your setup.py is valid. You're testing that your manifest.py is adding the files that you wanted to add. But still, sometimes you install a dependency in your local machine and your code works, but then someone downloads the file and in their machine it don't work. So to avoid this user problem of works on my machine, you can set up the Travis to like a continuous integration tools that are to like every time you commit your repository and you publish to GitHub or GitLab or whatever it is, it will run your tests on a separate machine. So at least you're sure that it works on your machine and also this other machine. Time is getting tight, so might go a little faster. So Travis CI is very useful, very common. It runs on Linux and it runs on OS X, although OS X is a bit broken for Python. You just create this travisci.yaml file, set the language, set what OS you want, the Python versions you want. There is this environment here is just to tell the talks what Python version it should run. So your install script is just pip install talks for the dependencies and just run talks. So Travis, it allows you running on OS X as well, but it's very broken for Python. You need to install the Python versions yourself. There are people that are able to work around that. You can Google it. There's Appveyor. That's the same thing as Travis CI, but for Windows machines. There are many problems that arise for things like, it's the file paths are backwards slash or forward slash, or file ending a line break is \n or \rn. So it's useful to run on Windows as well. That usually Python developers don't use. So same thing, same idea. Go there, install it. It will run. Coveralls is to track your coverage over time. So if you receive a new pull request, you can see, is this maintaining the same coverage? Is it lowering the coverage? So you can analyze if the new new code is being tested as well. Okay. Add your badges to your README so you can see at a glance the bit is passing, etc. Okay, done. Releasing a new version. How to release a new version. There's a small checklist of things to do, like decide the version number, write your changelog. Let's go over with it. Version number. Please just follow this semantic versioning. That's a pattern that many projects following on how to like what's version 1.0.3, for example. What does it mean? What each part does it mean? And if the new version is just a bug fix, and should I do like a new version 1.0.0? Should I bump that to 2.0.0, or should it be like 1.0.1, or what should I use? Look up semantic versioning. Use it. It's very straightforward, and maintain it. Write your changelog. Changelogs are very boring to write, but they're very useful, especially when you're adding new feature and new versions that are not backwards compatible. And so people using your code can, at a glance, just see, okay, this new version, will I have any issues if I upgrade to this new version or not? And if so, if there are issues, and how can I solve them? There is also this keep@changelog.com website that tells you a format for your changelog. Just follow it. Then you bump the version. It was 0.0.1. I'm not bumping it to 0.1.0. Run all the tests just to be safe that you're not like screwed up with the setup.py, for example. Create a new tag on Git, just git tag, whatever, and push it to GitHub. Then push a new version to PyPl. Just Python setup.py as this and be this will. The same command we run for the first version, and upload with Twine. And bonus, hopefully we have still 5 minutes, yeah roughly. Yeah, okay. So how to add dependencies to your package. for a package, you want to be as broad as possible to accept as much dependencies versions as possible. So people using your own code do not need to get your dependencies in your exact version. So add your dependencies to the setup.py file in this, just the install_requires and your dependencies. Try to get the minimum version that you know it will work with your code. And do not specify like version 2.3.4, for example. And add your dependencies to the setup.py and not the requirements.txt. Requirements.txt is more for like I'm building a website, or I don't want anyone to use this code. It's not to be reused by anyone. It's just a website, for example. But for library, use setup.py. And how to add an executable file. So I want to do like people be able to just run hello world on the command line and running it. So we just add a new file to our package, hello world/cli.py, for example. What this new file just imports the package and have this small function that just prints the results of the method. And in your setup.py, there's these entry points that you basically say, okay, I want, when installing it, I want you to create an executable with name hello world, and this executable is basically just need to run this method of this package of this class and return the value of it. Testing that with PyPy is very easy. With PyTest is very easy. Just need to create a test, and PyTest has these test fixtures that are very, very useful. Can't go over it now, unfortunately, but please read the documentation. And here we're just simply calling the hello world executable and checking the results back. And that's it. Okay? Pretty much done, yeah, cool. Thank you.
Thank you.